Judy Warner. Welcome to Microchip Masters 2025, where Microchip is celebrating their 25th anniversary of Masters. Today, I'm here by invitation of Microchip and Siemens, where they are announcing an exciting partnership that they've developed and they're rolling out at this show. We'll be talking to both executives from Siemens and Microchip, and we'll also be talking to the Siemens team in their booth here in the Ask the Experts area. Let's now jump into our conversations. Gentlemen, thank you so much for your time. And Matt, while we start with you, can you give us an overview of the partnerships that you've formed and give us a highlight of what the significance of that is?
Sure, Judy. So, as a lot of folk know, Siemens has a broad set of tools to help with electronic product development. We've been working with Microchip for over a year. Just about a year. Microchip bring to the table a tremendous amount of experience in what their clients are trying to do from a development perspective. And you can see from all the technology around today, all these solutions that they're trying to bring. And so what the partnership is really about is how can we help their clients develop their products faster and with higher quality? And how can we bring that knowledge that Microchip has of their components and how to interact with their clients and our design tools so that we can make that as seamless a transition as possible from thinking about what product I want to build to experimenting with the different chips that Microchip has that might help me build that solution to actually implementing that on a schematic and in a board and then taking it down into manufacture.
As you know, Matt, we've complained for years in our industries about being stuck in these silos, right? But it sounds like what you're saying is the partnership is about making that a reality with the power of Siemens tools and products that Microchip offers. Roger, what do you see as the major significance of this partnership?
So I think it enables, our clients to immerse themselves in our designs. It makes it easy for them to uh, uh, search for different components and how to add those into the system. So we issue a number of reference designs that our clients can use. And the Siemens tool chain makes it easy for them to bring the reference design in and then play around with what different types of components that I could use to achieve my design. Because, reference designs aren't really a one size fits all. I've always got to tweak that design to enable different features. And so the Siemens platform enables us to come in and analyze a range of components and then tailor it to the client's application specifically, and then quickly go from that phase all the way through schematic into PCB. And then now we're working on solutions that, looking into the future, help them go from the schematic all the way through coding into manufacturing.
So from really simulation or building out a application specific evaluation and then dragging that schematic right into Siemens tools. Is that what you mean?
So I think from my perspective, and Matt can speak to this maybe, it's going from paper napkin to production.
Okay. That's
So we like,
the dream, isn't it?
well, we talk about it in sort of three phases. One is sort of an engagement phase, right? I mean, there's all this rich information that's getting more and more complex. If you look at a data sheet, it can be 1,500 pages. You look at some of the reference design material. How can we help engineers to consume that material more easily? Then, Judy, as you said, sort of historically, everything was a little bit siloed, right? I might get the reference design from here, the schematic symbol from there, the PCB layout from over here. I have to sort of stitch them together to make sure that they all work well together. I might need some simulation models, etc. And so what we're really doing is trying to make that information as consumable as we can. And so, as Roger said, how can I go from a concept and then quickly go from the concept to an initial implementation and test that implementation? I don't want to have to keep building prototypes. I want to be able to test it digitally. That's a little bit of the digital transformation that we talk about. Then how can I take that and get it onto a schematic and then into a board and then make sure it's ready for manufacturing? So that's sort of how can we go from a disjoint flow into a flow that starts in the Microchip environment where all that rich digital information is, and then seamlessly moves into implementation and manufacturing.
And from Microchip's place, I mean, engineers, that's where they start, right? But let's dig in a little more specifically. Let's talk about the name of the product, and then let's talk a little bit more about how it works bidirectionally in your platform. So tell us about the PartQuest data enablement
Sure.
piece so our audience can understand more than theoretically what that user experience is going to be like.
Sure. And I have a little prop here. We can use that.
Okay, we like props.
Right. And so this is a great example of what Roger was talking about, where we went from a concept idea to a physical product really, really quickly. And there's a couple of products that fit under the name of PartQuest Design Enablement. And so what that really is right at the start, we worked on a conceptual design. And that conceptual design was really, I mean, it started off, as you said, as a napkin design that we wanted to do a memory game. And then we refined it a little bit, working with a partner called Celis to sort of say, I want this microcontroller, it's got to have this number of 4 LEDs on it, a buzzer, etc. It's this sort of simple memory game. Once we'd done that, we used PartQuest to simulate the boost converter on this, right? So that we could optimize the battery life, right? And so we went through some engineering work to be able to optimize what was our initial design and do that before we'd actually created any physical product at all. And that's part of what PartQuest does in terms of being able to simulate analog mixed signal circuitry. And if you look around the hall today, you see a lot which is sort of fits into that I'd like to simulate it before I build it category. We have some capability within there for collaborating. And so as I'm building it, the need for engineers to collaborate and look at the schematic and work on maybe marking up the PCB, seeing the bill of materials. One of the big challenges today in the industry is even though I might be able to design this, if I can't get all the components I need because the lead time is too long, I really want to learn that as early as possible. So part of the PartQuest environment is integrating the supply chain information as an example. So we kind of got this demo to the phase where we actually had a design, and then all those digital assets come into Expedition Standard. Expedition Standard is Siemens's design tool for schematic and layout, really for that sort of engineer who's doing both schematic and layout themselves. And it's part of our scalable solution. One of the nice things about the Siemens solution is you can start with Expedition Standard and do a design like this one, or as you scale up in complexity and size of design team, it scales with you until you're at that enterprise level and the complexity that we know that the enterprise has. So we pulled all those assets together. They're all digital assets. That's the sort of digital thread. Pulled them into Expedition Standard. We designed the physical layout. We used, and Roger can talk a little bit more about this, the Microchip AI to help program the controller on this, so that we've now brought in accelerating the software development portion of this as well. Completed that, took this into a manufacturing process, and through that streamlined process of going through the PartQuest design enablement environment, it's really integrated into the Microchip environment. So it feels that it's part of the Microchip experience. And then into the design tool when you're actually doing engineering, and then finally through to manufacturing.
So when you talked about availability of parts, right, or the product life cycle, when you're planning ahead, whether it's just for a prototype or going into pre or full scale production, that's a critical piece for engineers, as you know. So the bi-directional visibility that this gives engineers, then Roger, is that inside your tool, inside the Siemens tool, or is sort of a digital thread that just sort of lives there? That can give designers not only things like data sheet, but also give them far more visibility to know product life cycle and those things. Have it again, user experience wise. Are you are the engineers inside Expedition Standard and they're looking back, or are they inside of Microchip's environment, or they just have a digital grid?
So they're together. That's right. I mean, we want to make it a seamless experience. And so the PowerQuest design enablement platform is embedded into the microchip experience.
I see.
And so what you're really doing at that conceptual stage, where you're thinking about which microchip part you want to use, what are the set of maybe reference designs you want to look at, that's all in the microchip experience so that they've got all those assets available. And then they might want to decide, hey, I want to simulate this one, right? And they can do that. And they actually do that in the microchip experience as well, even though that's some Siemens technology behind that. And it's really only when they're committing to doing the design, they've kind of done that initial thought process of what components are going to be the right components, what are the right reference designs, that they'll come into a traditional design tool, Expedition Standard, then to do the schematic and the layout.
And what does partnering with Siemens do for Microchip and their customers in this round?
So if we take a specific example, right? You can go to our website. We're in development with this. You can go to our website, bring up a reference design. You can simulate the reference design. You can put probe points on the signals and see what the signals are. You can change input parameters. You can change components. So without loading any software, you just go to the website, you view the reference design, you tweak it, and then from there you can drop right in. So it's our reference design.
Got it.
You simulate it to how you want it to perform, and then you can drop it right into the schematic, and then you can begin editing the rest of the schematic. So, you know, it makes it really simple and easy for clients to evaluate different products without loading software, right? I have to download software and get licenses and things like that. It's kind of overwhelming. And so this makes it really simple and easy for clients to get started. Right? Sometimes the beginning phase, right, you're bringing all these pieces together, and, you know, Siemens platform helps clients with all of our data to do that very easily and get to a schematic much faster than they would in the past.
What sort of drove that partnership?
So, you know, Microchip started maybe as a more of a mass market, kind of a low to medium size client, a lot of academics. And as our designs and our products started to scale in complexity, that solution wasn't scaling, right? We couldn't bring in the complexity of the designs. We couldn't do the simulations. You know, those tools just weren't available. And even the workflows, it was just a simple schematic and PCB tool. We couldn't easily bring in, you know, like the simulation from the web, or we couldn't easily bring in, hey, you know, which parts are available. And so, you know, the Siemens platform really enabled that front end piece of it. And then, you know, something that Matt mentioned was the collaboration piece of it. I think he just mentioned collaboration, but on this specific design, I mean, we had, I think, engineers or developers in 5 or 6 different time zones on 2 or 3 different continents that were working together to get this done. I mean, this is a rather simple design, but, you know, we had Celis, we had Siemens, we had Microchip collaborating together within this tool chain. And right, it made it very easy for us to very quickly go through a design review, or someone did a simulation on the power circuit and, you know, we wanted to tweak that. And so all of these tools help enable us to get through that piece of it as well.
Are you using things like AI to get through, you know, hundreds? Can you query when you're trying to do the application specific thing? Can you query an extensive data sheet and find out specifically what you care about without downloading a giant PDF and flipping through it? Either one of you can respond to that.
So I think it's in both. So Matt can start with
Sure.
Expedition. I can start with Coding Assistant.
Right. So absolutely. You know, we can take a data sheet. We have what's called a smart data sheet assistant. And like you said, data sheets have now become really, really large. And what the smart data sheet assistant does is allow you to ask questions interactively of the data sheet, and it will just jump to the right place and give you the right answer. So if you want to know what the output voltage of a particular regulator is, it will give you that and jump right into that. And this is certainly an area that Roger and I think is where we want to collaborate further in the future, and not just around data sheets, but being able to interactively interrogate around the reference design. And so that you can understand what's in the reference design through that AI technology. And again, it's really about bringing that information in a much easier way to the engineer so they can understand it more and more quickly. And then Roger, on the software side, I think you can fill in there as well.
Yeah, so on the software side, for for this particular project, we used a product called MPLab AI Coding Assistant. And so we created about 80% of the code on this using AI. And part of that was we leverage data sheets that have been vectorized. And so you can query the data sheet and you can easily get out, programming specific things, bits and registers and settings for peripherals and things like that. So, again, 80% of my design was done by AI. So my time to market was very quick. I think it took, I think he wrote most of the code in like 2 hours.
So have you measured, is it a 20%? Is it an 80% time save for engineers?
I'd say it's a little early. Our experience with this has been it was a considerable time saver. And it's the reason that you said the digital thread's very often broken today, right? And so it's not only that you have to go and get the individual pieces of data, maybe from different places, you have to make sure that they're then correct when you integrate it together.
Yeah, there's that.
And so and so when we did this, a lot of those challenges just disappear because it's connected digitally. And then, as Roger said, a lot of the development time went down as well because we were using AI either for the software or for the initial conceptual design or for finding information in that sort of massive information that exists today. So a little bit early to come back and give you sort of quantitative answers.
Well, I think that's fair, Matt. So just on this device, this was a good place to give it a test drive.
Yeah,
To
absolutely.
do this in a more manual, traditional way versus how you did it. Just take a guess. We're not going to hold you to it.
I'm glad you're not going to hold me to it. It would have
I
taken.
could talk about the coding side. So
I think we went from multiple weeks right down into, I mean, to get the initial prototype was probably about a week or so, right? So I mean, it was really quick to get the initial prototype.
Right.
And I think, as Roger said, one of the key elements here is this was a team that was in multiple countries, right? And so it wasn't just about accelerating the design side, it was about enabling the collaboration and making sure that worked well and was efficient between people who were maybe in the US. I think we had some people in Europe, probably a couple of people in Asia who were on it as well. So having them all be able to see exactly the status of the design and collaborate on the design and have conversations about, what happens if you change this component? Is this going to work? And be able to do that digitally as well was a great saving.
Especially because often design teams are decentralized.
That's right.
Especially post-COVID. It's very impressive results. Well, gentlemen, is there anything I haven't covered? Anything else I should be asking you?
So I think one of the things is we see this as sort of a change in how engineers are looking to interact with companies like Microchip. And it's not so much I want a component here and now where do I get the sensor from, right? I mean, it's, hey, you've got a complete vertical solution. As Roger said, it might not be perfect for what I want, but it's pretty darn close. And now I want to be able to have an environment that lets me tweak that a little bit and then get into my product development side. From the Siemens side, Expedition Standard is a great starting point from our scalable solution. As it gets more complex, we have tools to help simulate signal integrity issues, power integrity issues, thermal issues, DFM, DRC. So it's a very broad solution that can grow with the engineers as they start to get more complexity into their design processes. We're super excited about the relationship with Microchip. It's really great. We've both got a great vision together, and we're looking forward to moving this forward and helping the industry.
Closing thoughts, Roger?
I would say stay tuned. There's a lot of exciting things that we're working on collaboratively to bring out even more tools that help Engineers get their designs done quickly and easier. So, this is the first and probably many steps that we have coming up in the future.
Well, again, gentlemen, thank you so much.
Thanks, Judy.
Thanks, Judy.
Thanks for joining us today. I hope you appreciated this insight from Siemens and Microchip here at Microchip Masters 2025.